Grade 6, open up your page, or your book rather, to page number 6. Let's take a look at what our next assignment's going to be about. The assignment itself is page 8, 4 to 13, some word problems, but we want to start on page 6, so open up to that page. Okay, let's take a look at the cute little turkey, and what does that turkey mean? The title says NCMINN Lead Turkey Production. What do they mean by that? They mean that the states of North Carolina and Minnesota grow lots of the country's turkeys. So when we look, North Carolina, do you see the number 46? That means North Carolina produces 46 million turkeys a year. And where it says 43.5 next to MINN, that means Minnesota produces 43.5 million turkeys per year. Arkansas, 27 million turkeys a year. Virginia, VA, 24 million turkeys per year. And MO means Missouri. Missouri produces 24 million turkeys. Now, let's look at the problem on the left side. It says, the graphic shows the top 5 turkey-producing states in a recent year. What is the total number of turkeys produced in the top 5 states? What's the total number? Question 1 underneath that says, do we have all the information to solve this problem? Can we figure out the total number of turkeys produced by the top 5 states? I think we can. Yeah. Any idea how you'd do that? Well, to me, we take those numbers, 46, 43.5, the number is 27, 24, and the number 24 again. Those 5 numbers, we're going to add them up. Now, notice I put the decimal point out here in that 5 there. All of these other numbers have decimal points here and here and here and here. We just don't always show them, but we need to line them up when we're adding. And now we just add up all the numbers. We got a 0.5 and then 9, 16, 20, 24. Carry a 2, 6, 10, 16. Now, is that the answer? Not really. Not really. Because remember, when we talk about North Carolina, they're not making 46 turkeys. They're making 46 million turkeys a year. Right? It's not 46, it's 46 million. So this number right here, 164.5, is not really 164.5 turkeys. It's really 165.4 million turkeys that are being produced. Okay. Let's go to the top of the next page where they're talking about television sets. It says at the top of page 7, color TV sets were first produced in 1954 in a mass-produced way, in other words, in large quantities. In that year, 5,000 color TVs were produced. How many years passed before at least 100 times as many were produced? Okay, so let's think through this. They're saying that in 1954, 5,000 TVs were produced or manufactured or made, right? And then the question says, when did at least 100 times more than that number get produced? 100 times more. What do you think we're going to have to do here? Well, we're going to have to take this number and multiply it by 100. And let's see what we get. First row, I'm going to take that 0 times all 3 numbers, and I get zeros. Second row, this 0 times all of those numbers. Right? Third row, this 1 times all of these numbers. Right? Whoops, too many. And we got all these automatic zeros here that need to be filled, right? Because when I take 1 times 0, that answer has to go here underneath the 1. When I take 0 times 0, it has to go here, of course. So now when I add these, I get the answer of 500,000. 500,000 is 100 times bigger than 5,000, right? Now let's look at the table. Where do you see a number that's bigger than 500,000? A number that's bigger than 500,000. I think that's 1963, right? In 1963, there were 750,000 produced. And that's more than 500,000, isn't it? So how many years went by between here and here? How many years went by? Well, to figure that out, I'm going to do a subtraction problem. Subtracting these two numbers. And when I do that, I get 9 years went by. There was a 9-year time span when they went from 5,000 to a number that's at least 100 times bigger. 750,000 is at least 100 times bigger. So that's our answer, 9 years later. Okay. Okay, let's go on to the next page. Let's start with problem 4 on the bottom of page 8. Problem 4 on the bottom of page 8. It is part of your assignment. I'm going to help you start off on this one. It says to attend a class picnic, each student's going to have to pay $5 for the transportation, in other words, the bus or whatever, and $6.50 for the food. So if I'm a student, I got to pay $5 and I've got to pay the $6.50. So one student, how much do they have to pay in all? Wouldn't that be 5 plus the $6.50? Wouldn't that be $11.50? Yep. And then it says, what if there's 300 students in the class? And if there's 300 students, how much money are we going to be making? Wouldn't that be 300 groups of this $11.50? Wouldn't it be? Aren't you going to have to take this number and multiply it by this number? I'm going to let you finish this problem on your own. This is the way you work on problem 4. But go ahead and finish it on your own. Let's look at number 5. If Isaac gets an email every 20 minutes during the workday, how many emails would he expect to receive between 8 a.m., which is 8 in the morning, and noon? How many emails would he expect to get? He's getting one every 20 minutes, right? Every 20 minutes. Here's how I figure it out. Problem 5. When does he get his first email? He gets it at 8 o'clock, right? Then he gets his next email at 8 to 20, because they're happening every 20 minutes. Then his next email at 8:40. And then 8:40 plus 20 gets us to 9 o'clock. So he's getting an email, an email, an email, an email. So far he's gotten 4 emails, hasn't he? And we've gotten from 8 o'clock to 9 o'clock. We keep the pattern going. 20 minutes later would be 9:20, then 9:40. Then 10 o'clock. I'm going to jump down here. Then 10:20, 10:40, and then 11 o'clock. And then 11:20, then 11:40, and then 12 o'clock. Well, so far, he's received 4 emails, hasn't he? Oops, this is off the screen a little bit, sorry. So far, he's received 4 emails from 8 o'clock to 9 o'clock. If we keep this pattern going, how many total emails does he get from 8 o'clock all the way to noon? Okay, I'll let you figure that out on your own. Okay? Let's go to problem 6. A video store took in $5,400 in video rentals. People paid them $5,400 during July. January sales are supposed to be double that amount. Okay, so July, this is problem 6. July is $5,400, and January is supposed to be double that amount. What does the word double mean to you? Doesn't that mean taking a number and multiplying it by 2? So if I said, what's double the number 10? You'd say 10 times 2 is 20, right? So what are we going to do here? If these sales in January are double this amount, you're going to have to take that times 2, right? 0, 0, 8, 10,000. So January must be $10,800 if they're doubling. Now let's look at the rest of the problem. If videos are renting for $4 a piece, how many video rentals would they be expecting in January? Every time they rent a video, it costs $4. And in January, they pulled in $10,800. So isn't that a whole bunch of people paying $4 at a time? And ultimately, at the end, they bring in $10,800? Yep. So if I want to find out how many videos were sold or rented, that would be this 10,800 divided by the number $4. And if I figure that out, that's going to be the amount of videos that got sold. I'm going to let you figure that one out on your own. Let you finish that one on your own. But we at least got you started on it, okay? Okay, number 7. Ooh, number 7's a tricky one. Not too bad, not too bad. The Indianapolis 500 Motor Speedway has 3,200,000 bricks that lie beneath the 2.5 miles of track. If that's true, how many bricks lie under just 1 mile of track at that same racetrack? So they're saying 2.5 miles of track have 3,200,000 bricks. And they want you to say, okay, if I only looked at 1 mile, how many bricks would that 1 mile be? 2.5 miles, 2.5 miles is this amount of bricks. 1 mile would be how many bricks? So if you only took a section of the track, 1 mile long, and you counted all the bricks, how many would there be? Any thoughts on how you're going to solve that? Guess what? This is a division problem as well. We have to divide the amount of bricks by the amount of miles. And when we do that, we're going to end up with the amount of bricks per 1 mile. So it's really this problem divided by this number. But that's a little tricky, 6th graders. You've been told in the past that you can't have a division problem where there's a decimal number inside that. So we're going to move it over 1 spot. And when we move that over, we also got to move this decimal point over 1 spot. So it ends up being 25 into this number, because we add a decimal point to this. It ends up being 32 million divided by 25, because I moved that decimal point over 1 spot. I'll get you started on this. 25 goes into 32 once with a remainder of 7. Let's bring down the 0. Can you see that? Oh, not quite. Sorry. So 25 goes into 32 one time with a remainder of 7. Bring down the 0. 25 goes into 70 twice. So we get a 50. Bring down the 0. 25 goes into 200 8 times, because 8 times 25 is 200, right? All we got left is zeros here, right? So it sounds like the rest of this problem is going to be pretty easy. 25 goes into 0 times, and we keep bringing down zeros. 25 goes into 0 times. Keep bringing them down. 25 goes into 0 times. 0. And 25 goes into 0 times. And there's our answer, 1,280,000. What's the label for this? Bricks. That's a toughie. Okay? Okay, so I did, or at least helped you with the first 4. Try to see what you can do with the rest. numbers 4 through 18. Thank you. Have a good